Alrighty guys, we got the next video here is going to be 6-6, rational exponents. Yes, rational means fractions if you remember, and exponents are hard the way they are. And so now we're going to throw fractions into exponents. This should be fun. I said that a little sarcastically, you can probably pick up on that, but seriously though, this is one of my favorite lessons, I guess. Because I kind of like to think about all my exponents and all my radicals when they are rational exponents. I know you guys think I'm nuts and crazy and weird, and this statement won't help that, but I like fractions. And I think this helps kind of tie everything together with what the past two videos have been about. If you understand exponent rules, if you understand fractions, you'll understand why we would have been able to do some of the tricks and some of the shortcuts that we have been able to do. So here we start with this concept of b to the 1 over n. I'll read these to you. For any real number b and any positive integer n, b to the 1 over n is equal to the nth root of b. Obviously, except when b is less negative, because that don't work. And n is even. So, when b is less than 0 and n is even, a complex root may exist. So those don't come up too much. I try to keep eyes out of here as much as possible with this. So if you notice right here, this is kind of the one you want to do. 27 to the 1/3. You can rewrite as the cube root of 27, and we all know the cube root of 27 is 3. Now this is whenever your numerator is just 1. Down here it talks about when you have a bigger power. So you can kind of read the words, put the words in your notes if you need them. I'm going to skip down to this example here. You have the same thing, except this time instead of 1 for your numerator, you got 2. So you have the cube root of 27, but this time that guy is squared. So that's kind of the difference. If the power on the outside, or the power in the numerator goes, or the number in the numerator goes to the power on the outside. So the cube root of 27 is 3, and then 3 squared gives you 9. So we're going to practice first real quick with rewriting. So we're going to write the following in exponential form. Okay, so these will just make fractions. So your index, and this is important to make sure we get right, your inside stays the same. Your index becomes your denominator. And then if there's no power on z, it goes to your numerator, or 1 goes to your numerator. Okay, so the 4th root of z is z to the 1/4. The 8th root of z is z to the 1/8. So then where it gets a little messy is, just if you kind of keep true with that, then you don't need to worry about powers, they go in the other one. So the cube root of c to the -5th is c. 3 goes in the bottom. Oop, let me get it out of the way just a little bit. There we go. And then -5/3 goes on top. So the power from your c goes to the numerator here. In a similar fashion, you can go the other way. So the x to the 1/6 is going to become the 6th root of x. A to the 1/5 will become the 5th root of a. And then, like I said, you kind of stay with the same course. So your denominator is your index. So the 4th root of d to the 7th. Now there's two ways, if you've noticed, there's two ways you could write the power. You could also do it as the 4th root of d all to the 7th. It's not going to come up too much for me to care about which way you do it. So whichever way for that example you prefer, if you prefer inside with the variable or the outside the whole radical, either way is fine. So for these, they have their own set of rules. If you look, it's a lot similar to the ones we wrote a lesson ago. Just expressions with rational exponents. They're considered simplify when, once again, you have no negative exponents. No exponents that are not positive integers in the denominator. So you cannot have anything besides positive integers as exponents in the denominator. No complex fractions, and the index of any remaining radical is the least number possible. As long as you kind of pay attention to the one example we're going to do regarding that kind, you'll be fine. So here's kind of an example I was talking about at the very beginning with why I like rational exponents and why I think if you can think with fractions, they're easier than radicals are. 81 to the negative 1/4. So obviously we got to make that positive first. So we're going to move that to our denominator. So 1 over 81 to the 1/4 power. That's first up. And instead of writing it into radical form, what I'm going to do is I'm going to take, obviously we've got to get rid of that fraction power. So we know it's going to be over 1. I'm going to think to myself, how can I rewrite 81 to a power of 4? So if I try that, I know it's going to end up being 3 to the 4th. And that just changes 81. So that whole guy is still to the 1/4 power. Now you can go through and apply your power of power rule, which means you multiply the 4 and the 1/4, which gives you 3 to the 4/4, or that gives you just 1/3. Okay, so as we go through these problems, I'm going to show you guys how I like to do these, how I kind of take my shortcuts with these problems, kind of go through and look at different things and kind of shortcut it so that way I don't have to keep going back to radical form. I think I like rational exponents better. I'm happy once I get to this lesson because I can finally teach it this way. I kind of struggle with doing 6-4 and 6-5 the way the book does, because once you get to 6-6, in my head at least, it makes everything easier. You could just as well, if you wanted to, from here, make it 1 over the 4th root of 81, which is going to end up in this case being shorter, but just be cautious. If this isn't a perfect, then you have to rationalize. And that's where rational exponents becomes a healthier choice, because you may have to rationalize this down here. So proceed with caution if you go back to radical form. I'm a rational exponent fan. And so here's another example of that. 216 to the 2/3 power. Excuse me. So your most important number obviously is your base. So we need to rewrite it. And we want to rewrite it so that your denominator here and the power that'll be here matches. So 216 is going to be 6 cubed, one of the ones you need to know. And so you have 6 to the 3rd to the 2/3, so you multiply that out. So that gives you 6 to the 6/3. Simplify that, gives you 6 squared, which gives you 36. Okay, so I know some of you thinking like, yeah, more when we get this is pretty simple. You know, I could just use it in my calculator, or I can just go back to rational. Well, I have 2 comments for that. Number 1 is this. Hopefully you're paying attention now and not, playing PlayStation at this point. Number 1, there's going to be a no calculator portion on this test. Always is, because I don't want you just going 216 exponent 2/3 enter. So make sure you know how to do this process here, because there will be a no calculator portion on your test for Chapter 6. Secondly, we're going to get to an example here in a little bit where it's going to be kind of difficult to do it in your calculator. So I kind of just want you guys to just kind of get away from using your calculators as a crutch. And one of the examples is this one here. I don't like the placement of this example in the book. It just basically asks you, do you know how to multiply and then add your exponents? And you say yes. So a to the 2 sevenths times a to the 4 sevenths gives you a to the 6 sevenths. 2 plus 4 gives you 6. You're adding your exponents together. If you need to see it a little more, pause the video, because otherwise I'm moving on. Alrighty, so here's kind of what I was talking about with not doing your using your calculator for these. B to the negative 5 6 is very similar to ones we've already done. First thing you want to do is kind of once again make that exponent positive. You always want to do that first. Then it turns into kind of a rationalizing problem, because obviously it said, remember if you recall, in those rules in the very beginning, you can't have rational exponents in your denominator. So what we're going to do here is basically rationalize it, and we're going to rationalize it once in such a way that we get to that next whole number as far as your power goes. So using the last example, knowing you add your exponents, you think to yourself, all right, 5 6 plus what's going to give me that next whole number? And that's easy, because that's just going to be 1 6. You're 1 6 away. So you multiply top and bottom by 1 6, which gives you B, so 1 6 on top, over B to the 6 6 on the bottom, which obviously simplifies down to B to the 1 6 over B. Okay, another example of what I was talking about where I like rational exponents. Here's a potential problem that I could have given you a while ago. 4 through 27 over the square root of 3. Now, I may not have mentioned this in the video, and since I'm kind of going through all these in one day and making these all, I'll mention it in class, so you'll already know this. If you have different indices, you can't do anything. So right now, without knowing anything, you can kick back in your chair right now and can't do it. But that's where the beauty of, yes, I just said beauty in math, the beauty of rational exponents comes, because now we can simplify this. So convert these into rational exponents. So you have 27 to the 1/4 power over 3 to the 1/2. Once again, no calculator section. Here's what I'm going to tell. Here's the trick that I'm going to show you. I'm just going to kind of work it, and then I'll let you guys be amazed at my insights on the problem like this. You don't want to rationalize it just yet, if that's what you're thinking, because obviously you have different bases. So make them the same base. So you can rewrite 27 as a base of 3, because 27 is 3 cubed. And that 27 is still going to be to the 1/4 power, all over 3 to the 1/2. Now simplify your power of powers. So you have 3 and 1/4. Multiply those, you get 3/4 over 3 to 1/2. Then the nice part about this, you don't even have to go rationalize. You have the same bases to exponents. You can just subtract them. So you have 3 to the 3/4 minus 1/2, which gives you 3 to the 1/4. Now, this will be like the only case where you have to do this. Since you started in rationals, you need to convert your answer back to rationals. So this goes back to being the 4th root of 3. So if you start in rationals, you convert back to rationals. Just so I can say I've said it, if you start with rational exponents, you go back and you want to convert to radicals, you convert back to rational exponents at the end. Whatever you start with is what your answer should be in. But that's, to me, this has always been an amazing kind of thing. You can take different indices of radicals, something you've been told all your life, you can't mix up with, and then all of a sudden you can do stuff, you can simplify them. So this has always been one of my favorite topics to talk about, because it kind of it opens a lot of different doors, and it allows you to take problems that you haven't really thought you could do, and now do them and simplify them and make it a lot more simple than the 4th root of 27 over the square root of 3 and just make that, the fourth root of 3. So moving on, we have one more here. Like I said, the problems kind of correlate all through the chapter with different types and stuff. This one here, you probably already guessed what you need to do since you see the binomial in the denominator. Yep, you need to conjugate. So you have 3 x to the 1/2 minus 2 on top and bottom. And then you're going to FOIL that out. So this is where your FOILs can get just a little bit ugly or a little nastier with the fraction exponents here. So just be careful with those. Do the top first. So x to the 1/2 times 3. X to the 1/2 gives you 3x minus 2x to the 1/2 minus 6x to the 1/2 plus 4, and all over FOIL the bottom out. So 3 times 3 gives you 9. X, remember they're conjugates, so the middle 2 should cancel, minus 4. Simplify what you can up top. Okay, remember like terms are defined to be the same basis, same exponents, so you can't do anything to the x and this x to the 1/2 term, but you can add up the x to the 1/2 terms. So equal 3x minus, minus 8x to the 1/2 plus 4 all over 9x minus 4. Keep in mind you cannot simplify, cancel out those 4's. So that's the end of this one, guys. Your assignment for this one will be page 426, 16 through 48 evens.